Hi dears, welcome to today's session on electronics communications. This is one of the basic topic for competitive examination like UPSC, NDA, NCET, CUET, IIT, JEE, EAMCET, EAPCET. So here I am going to present 50 MCQ questions. So before I am going to 50 MCQ questions, I would like to give you basic concept. I am not taking a lecture, just I am start with few basic concept. After that, we will start MCQ series with your permission. Thank you. So what is semiconductor? As you know very well, solid material, according to the band theory of solid is classified into three different characters. One is called conductor, semiconductor and non-conductor. What is conductor? The body which exhibiting conductive property, which allow electricity from their body, that is called conductor. Example, metals. Metals are the good conductor of electricity. Similarly, the bodies which do not allow electricity, such as plastic, wood, they do not allow electricity. So that is the reason they are called a non-conductor insulators. We can also consider as insulators. But some bodies, they exhibiting sometimes conductor behavior, sometimes non-conductor behavior. And that bodies we called as a partial conductivity body, and that is termed as semiconductor. Example, silicon and germanium. Semiconductors have the conductivity between conductors and insulators. Example, silicon, germanium are commonly known as semiconductors. Based on the conductivity character, these semiconductors are again classified into intrinsic semiconductor, extrinsic semiconductor. A pure semiconductor such as silicon, germanium, where number of electrons is equal to number of holes. Number of electrons equal to number of holes. Where electron negative charge, hole is a positive charge. Whereas extreme semiconductor, based on the doping character, again it is, we will consider one is p-type and n-type semiconductor. Extreme semiconductor are used for our multi-purpose applications. There is a limitation application. We need wide range of applications, so that we need extrinsic semiconductors. So here, at room temperature, thermal energy breaks covalent bonds, so that equal number of free electrons will equal to holes. That is about intrinsic semiconductor. Extrinsic, because of doped. What is doped? Adding of small impurity. Adding of small impurity. Small impurity adding. Adding of small impurity, that is called as doping. Based on the doping, this extrinsic semiconductor again classified to n-type and p-type. N-type, how it is formed? Pentavalent impurities such as phosphorus, arsenic, antimony, they are added to pure semiconductor. What is that one? Intrinsic semiconductor. So pentavalent, it is doped to intrinsic semiconductor, then that is called n-type semiconductor. Tetravalence, pentavalency. So here again pure semiconductor like intrinsic is doped by trivalent, then it is called as the p-type semiconductor. Trivalent impurities such as boron, aluminium, indium are creating p-type semiconductor. So that here tetravalency, that means intrinsic semiconductor, whenever it is doped with the pentavalent, that is form n-type semiconductor. Tetravalency, that means intrinsic semiconductor, when it doped by trivalent elements such as boron, indium, it create p-type semiconductor. So here p-type semiconductor consists of majority carriers or holes. N-type semiconductor consists of electrons. p-n junction. So because of this semiconductor, a junction is formed and that is called as p-n junction. When p-type, n-type semiconductor join, electron diffuse from n to p. Electrons are diffused from n-type semiconductor to p-type semiconductor when both semiconductors joined. Then holes are shifted to p to n-type. This is holes, this is about electron. So electrons diffuse from n-type semiconductor to p-type semiconductor. Holes are shifted to p to n. This recombination near the junction create a depletion layer. So this layer with immobile, no movement of the ions. So they create 0.7 volt for the silicon. So this is called the layer, the region between p-type and n-type where equal number of electrons and equal number of holes are presented. p-n junction is biasing. Biasing means what? Adding of potential. Based on the biasing, the p-n junction is considered as forward bias and reverse bias. What is forward bias? Positive terminal to p side, negative terminal to the n side when connected, then the depletion layer between p-type and n-type is very small. Because the majority charge carriers easily flow. Resistance is minimum whenever we have forward bias. Whenever it is a reverse bias, what is reverse bias? Positive terminal is connected to n side, negative terminal is connected to p side, so that depletion layer is widened. So that electron flow is stopped. That means high resistance. Here in there minimum resistance. Here maximum resistance. More resistance is presented, less resistance is opposite to the current. So in reverse bias, more resistance, so less current is flow. What are the applications of this p-n junction? They are used as a rectifier, they are used as the LED diodes, they are used as photodiodes, they are used as Gina diode. Combination of diodes will create, combination of semiconductor will create junction that is called transistor character. So here, like sandwich shape, this is n-type semiconductor, this is p, again n. So p-type semiconductor combined by opposite sides of the conductors, semiconductor, p is n is by pp, then this is called pnp and pnp. This type of the tripolar character we called as the transistor. That means transistor two types, one is npn transistor, one is pnp transistor. Three doped regions, one is called emitter, base, collector. Emitter, base, collector. We have three different characters. So here the sequence here, emitter is doped heavily. You need to understand here. Sorry. So emitter doped heavily, base is thin, means moderately, less doped base, moderately doped, lightly doped by base and moderately doped by collector. So emitter is highly doped, base is lightly doped, collector is highly doped. NPN transistor diagram. Here you can see here, transistor is work as a switch. These are about the logic gates. Digital circuits uses binary that is 0, 1. Basic gates are what? OR gate, AND gate, NOT gate. Universal gate is what? NAND gate. NAND gate is known as the universal gate. So basic or AND NOT, they are nothing but basic gates. NAND gate as universal gate. You can see here. AND gate. What is AND gate? You can see here. Just like a multiplication, you go with the AND. This is a symbol for the AND gate. A and B are the inputs. X is the output. 0, dot, 0. AND means just you represent by multiple symbol. Otherwise, you can take dot. A dot B. 0 dot 0. 0 means what? Minimum. 1 means maximum. 0 dot 1. 1 dot so 1. So when two inputs are minimum, when it is minimum. When two, you can go with it. When two inputs are maximum, the output will be maximum. This is for the AND gate. We are coming to the OR gate. When two inputs are minimum, output will be minimum, rest it will be max. Opposite of AND gate, NAND. Opposite of OR, NOT. So you can see. Then communication systems. Here elements, transistor, channel, receiver, or we have the part of the communication system. That is frequency maximum to frequency minimum. This is of the bandwidth. Propagation of electromagnetic waves. We know ground wave, sky wave, space wave. Ground waves follows earth curvature, which is having less frequency, shorter distance. Sky wave reflect from ionosphere, which is having medium frequency. Line of sight, LOS, high frequency, used for TV satellite. The first question, in intrinsic semiconductor, number of electrons and holes. That I am not taking all options, I am just going with the direct answer. So here, because I don't want to go with the more time. So here in intrinsic semiconductor, the number of electrons and holes are equal. So that here you can see here number of holes and number of electrons are equal in intrinsic semiconductor, that is Ne equal to NH. That is about the intrinsic semiconductors such as silicon and germanium, which are the fourth group of elements. So here second question, pentavalent impurity in silicon produces. So silicon is a trivalent, tetravalent element, which is nothing but intrinsic semiconductor. To the intrinsic semiconductor we added pentavalent such as phosphorus, antimony, arsenic. Then which type of the semiconductor will be formed? So here when we are added pentavalent, then it is creating N-type semiconductor. Which type? N-type semiconductor. So here there are extra electron formed. Extra electron from donor atoms. So here when intrinsic semiconductor, it is doped by pentavalent, it is giving which type of semiconductor? N type of semiconductor. Coming to the depletion region in a PN junction contains. What contain depletion region? The depletion region, see, this is P-type semiconductor, N-type semiconductor, but when you join these two semiconductor, there will be a layer between the P and N, and that we call as depletion layer. And this depletion consists of equal number of positive and negative ions, which is nothing but fixed ratio, and that we call as immobile ions, not movable. Coming to in forward bias, a PN junction diode, the depletion layer. So what is this is, if you are thinking this is a junction diode, positive terminal is connected to P-type, negative terminal is connected to N-type. So now the depletion layer is decreasing. So that the depletion layer will be now applied voltage opposes built-in potential, so that when it is forward direction, the depletion layer size is decreasing, so that it conduct more current. Coming to the fifth one, in reverse saturation current. In PN junction diode is what? In reverse saturation current, see, in reverse saturation, that is nothing but minority carriers. The current from thermally generated minority carriers in reverse. So minority carriers are generated in reverse saturation, that is of PN junction diode. So Coming to in NPN transistor, question number 6, the majority carriers in the emitter, NPN, N-type, P-type, N-type. So here the majority carriers in the emitter, that is about electrons, So heavily doped, emitter is heavily doped, base is lightly doped, collector is moderately doped. Question number 7, a transistor acts as a switch in digital circuits. So at what region? That is at saturation and cutoff regions. Saturation is about the closed switch, cutoff is about the off. Switch on at saturation, switch off at open. The output of NAND gate is 0. When? So that is NAND gate, it is opposite to the AND gate. So that you can take, for example, I am taking AND gate A. Okay, I will explain, don't worry. A, B, and negative of AND is, okay. So 1, 0, 0, 1. So that what you will get better? 1.1. Here 0, 0. What is AND? When both inputs are maximum, the output will be maximum. Others it will be 0. Now opposite this one. 0 is minimum to opposite 1 max here. So you see opposite. So here all inputs are 1. Here it is 0, then here it is 1. So that is about NAND gate is invert of the AND gate. Question number 9. NAND gate can be obtained from NAND NAND gate by opposite of AND and AND. So here trying both inputs together. Both the inputs together we will get a NAND gate produces NOT gate. AND gate using only NOT gates require how many? NAND gate followed by NOT gate. OR gate using only NAND gates. This is not as part of the NDA, but you can go just. OR gate using only NAND gates is obtained by, that is about NAND gate. NAND gate is called universal because that is about any gate can be made from it. Bandwidth of signal is what? Bandwidth of signal is F max minus F minimum is about bandwidth. Range of frequencies occupied by signal. Ground wave propagation is suitable for low and medium frequency. Ground wave, low and medium frequency. Sky wave propagation occurs due to reflection of ionosphere. So that is about ionosphere reflects medium frequency waves, that is about sky wave. What is space wave propagation is? Space wave propagation is direct visibility required for TV and FM, which is nothing but high frequency, that is LOS, line of sight. Question number 17, necessity of modulation, that is to reduce antenna size, increase its range, we need modulation. High frequency carriers travel longer efficiently. In amplitude modulation, the frequency of modulated wave is, that is about same as carrier wave. Question number 19, modulation index mu in amplitude modulation is what? It is ratio between AM by AC. What is that one? Amplitude message to amplitude carrier. Detection of AM wave is done by, how you detect AM wave? Amplitude modulation or amplitude message, that is by envelope detector. Question number 25. P-type semiconductor majority charge carriers. Majority carriers are in P-type, that is about majority carriers are holes. So here that is about holes. Barrier potential in silicon junction is, barrier potential in SN semiconductor, that is about 0.7. The barrier potential in SN junction, that is about 0.7, which is the standard value. In unbiased PN junction, the depletion region as immobile, not charged. We are not giving any external potential, so that is, it is in remain stages, that is immobile. Transistor as a switch. As switch is used in where? It is used in digital circuits. Question number 25. Binary number system uses what? It is uses 0, 1. That is about 0 and 1. 0 and 1. Question number 26. Reverse bias PN junction. Reverse bias PN junction diode behave like. It is behave like, that is a open switch. That means high resistance. Question number 27. Okay, I forgot the question, sorry. TV broadcasting uses, question number 28. TV broadcasting uses space waves, which is line of sight, LOS. In AM, overmodulation mu greater than 1 causes distortion. What is that one? Distortion. Question number 30. Channel in communication system is transmission medium. Transmission medium. Majority carriers in N-type are, that is about electrons. Donor impurities provide extra electrons. Depletion region with increases in, so where depletion region width is increased, that is about reverse bias. NAND output is high when, that is about any input you can solve. NAND is opposite to the AND. Okay, clear? Question number 34. Sky wave is affected by, so that is about day-night ionosphere changes. Day-night ionosphere changes. Day-night ionosphere changes. Okay, question number, ionization vary with the solar radiation. Carrier wave frequency in AM remains unchanged. In AM, carrier wave frequencies remain unchanged. Question number 36. Emitter in transistor. Emitter in transistor is highly doped, whereas base is light, collector is moderate. Logic gates are building blocks of what? That is about digital circuits. 38. Bandwidth is important for what? For channel capacity. Determine data rate and signal quality. Ground wave is used for LOS, short distance, not LOS. Ground wave is about the short distance low frequency. Question number 40. In reverse bias, current is what? In reverse bias, the current is, that is about very small. To make NOT from NOT, what we do? We have to tie inputs. Both have to be, and opposite is what? NOT. So here both inputs should be same and inverted output. So here, question number 42, I am taking firstly, modulation allows, what allows? Modulation allows multiplexing smaller antenna long distances. So it is allowing multiplexing smaller antenna and long distances. Envelope detector uses for what? It is used for diode and ORC. Space 44. Space wave requires what it required? Direct line of sight. Direct LOS. No reflection is for high frequency because LOS already is having high frequency. In NDC semiconductor at 0 Kelvin. That is behave like a insulator. Remember here, at room temperature, if you are increasing temperature for this semiconductor behave like a conductor. But here, intrinsic semiconductor at 0 Kelvin temperature, it became like an insulator. In PN junction diode is forward bias act as, that is about low resistance. That is about low resistance. Universal gate along with NAND is, that is about NOR gate. PN junction in forward bias act as, that is, it is act as, the PN junction in forward bias act as low resistance, high current. Okay, clear? So that is universal gates along with the NAND gate, that is about the NOR gate. So NAND and NOR gate both are known as universal gates. 48, AM wave detection recovers, that is message signal. 49, the ionosphere reflect waves of frequency, that is about 3 to 30 megahertz, suitable for sky wave. Last one, NON is preferred in ICs because it is universal and economical. Thank you. I will add lecture and some more important concept related to a special exclusively for IIT JEE.